Cool. All right, so homework review. Let's talk about that first. I'll just kind of just scan through it. It's pretty short. So 7140 is midpoint. Define midpoint, just average the X and Y's, not that hard. So that's A and B. And if you do get a fraction, you can leave as a fraction, you can leave as a mixed number, you can leave as a decimal. It doesn't really matter to me, just as long as you do it correctly. So all's good there. Okay, the must be could be. We had a quite a spirited discussion about it during B period. What I mean by spirited is it was good. Like no, there wasn't like any like animosity or anything, but it's just I could sense some frustration. Like yeah, it's a little confusing, right? Like it's kind of ambiguous. Like could it be this? Must it be this? And I think the wording is a little messy too. So I'm going to talk to Mr. Davidson more about it tomorrow morning. Have more clarity on Wednesday because I could see some of the ambiguity that's happening here. I could totally get that. It's really good. That's why I don't know yet. That's what I just said. I'm going to have a discussion tomorrow. Tomorrow, so I don't know. But maybe we can think of a more creative way of still kind of assessing that without any of the confusion. Because here's the thing: like my quadrilateral has two right angles, so it totally could be a square. A square has four right angles. It could totally be a rectangle. It could totally be a kite, because a kite could look like this, right? Um, you could draw it like this in this manner, where those are right angles. That's possible. And this is like 40 degrees. That's 140 degrees. I know I didn't do this to scale, but that's a possibility that could happen. A right trapezoid. So just this statement alone, does it lead us to say that it has to be the shape 100% guaranteed? Not really, right? Like if I told you I had two right angles, now here's if I said exactly two right angles, then of course it's not a square. Of course it's not a rectangle. It might be a kite, but right trapezoid would make sense, right? If I had the word exactly. So that's why I got to talk to Mr. Davidson about that because he's taught this class for several years. He probably has a little more background experience with how students have gone about these questions. Because I do think it's kind of ambiguous personally. If I had at least two right angles, okay, well then sure. Must it be a right trapezoid? Well, not really. If you have the word at least. So I don't know. It's a little tricky. But I do know those four shapes would at least fit that description. My diagonals are perpendicular of the quadrilateral. That alone is not enough to say it's a square, a rhombus, or a kite. You would need more information. Like you'd also have to say, oh, all the sides are the same, and the diagonals are perpendicular. Then fine, I've got a rhombus. Or if you said, oh, but also all the angles are right angles, then fine. Then you can say it's a square. And it must be a square if it was that the case. So it just depends on how it's worded in some ways. So I'll have more clarity about that on Wednesday for you guys. For 7146, these are the equations of the lines for diagonals of a quadrilateral. Well, what you need to recognize the slopes are opposite reciprocals, right? So therefore, they're going to be perpendicular. And if they're perpendicular, then it could be a kite, rhombus, square. We talked, it could be, right? Not guaranteed, but could be. Also, we do know that one of the diagonals will be cut in half. They kind of talk about that, where E is the midpoint of CD. So there you go. Just locate C and D and whatever. Um, these here are just more old school stuff, right? Like, oh, trigonometry, cosine, sine, things like that. We said skip B, but B you could do though. If that's 25, what's that angle then? Also 25, how do I know that? The sides opposite are the same, right? And then if I want to find X, what do you think I should do to find X? Yeah, cut that in half, exactly. Thank you, Griffin. Yeah, cut it in half. You got 7.5 in X and 25 degrees. Now here's the deal. Now we have enough information to solve for X. We'd have to use trigonometry. I'd use a cosine and solve for X. And X would be on the bottom because it's the hypotenuse. So you could do it. 153, if you plot the points and look at it, well, not look at it, but investigate it, you see the slopes are negative reciprocals. And of course, you have two pairs. The slopes are also the same. So you have not just parallelogram, you got at least a rectangle because you got these right angles. But if you dig deeper and look at the side lengths, all the side lengths are the same as well. So you got right angles and side lengths are the same. That's totally a square. That's why B is a square. And which diagonal is longer? Well, that's a trick question. They're the same length as a square. Um, and to find it, you could use Pythagorean theorem or business formula and find a midpoint of MN. Well, I know you guys can do that. It's not hard. Just average X to Y's. Okay, we talked about this mid-segment theorem. Remember, the mid-segment is a segment that connects the midpoints of two sides of a triangle. That's always going to be half of the base, or the base is twice the mid-segment. They're also parallel as well, the mid-segment and the base. So you could just like multiply 3n plus 5 by 2, so equal 5n plus 11, work it out. Part B, you get the same kind of thing happening there. Um, so all is good there. Um, yeah, it should be pretty straightforward. If you have the perimeter rhombus, to split up 4 ways and split PR halfway and then use Pythagorean theorem to solve for B. You should know that these are the same. Angle 1 is the same as 2x plus 17. And angle 1 and x minus 5 have to add to 180. So therefore, you can just replace angle 1 with 3x plus 17 by substitution, solve for x. If you have a kite, opposite angles are always congruent. Just got to know that. These are the same, so semi-equal, solve for x. Everything's A-okay. Unless we could be. Okay, if you're told the diagonals of a quadrilateral are equal, well, I don't know what it has to be. Could it be a rectangle, square, or isosceles? Sure. But guaranteed is it any of those three? No. My quadrilateral has one right angle. Well, that's any quadrilateral could have that. So I don't know. Or my quadrilateral has one pair. Now that's the thing. One pair of equal adjacent sides. Is it exactly one pair? Or at least one pair? See, again, it's kind of ambiguous, right? Um, if it's a pair, then it should just be a kite. But it could be a trapezoid, I suppose, too. So that's why it's ambiguous. That's why it must be probably none makes sense. But maybe it could have two pairs. So rhombus and square is kind of in play as well. So that's what's happening. Okay, so we do want to finish off the notes. So if you guys can get your notes packet out. We got to finish one problem in 732. And we got to do 733. I'm not doing all 733. There's a little like activity, but it's their fifth class of the day, and it's feeling like spring now, which is kind of crazy. I'm sure it's gonna feel like winter very soon again, but we won't do activity. I want to kind of go light with you guys as usual on Mondays. So yeah, so let's finish off the notes on 732. We want to go to the problem 7128 and have a discussion there. We'll also discuss well, actually, we won't discuss 722 now. I'm going to skip that. Then we'll discuss 733. And this table might help the whole must be could be thing, perhaps. And then I'll talk about the test with you guys. And then you guys can start reviewing for the test this week. Our test is next Monday. So be prepared next Monday. I know day after Super Bowl, but yeah. Are you going? If you're going, then get your work done early. Start studying now, right? So, because if you're going, you're going to be busy all Sunday. All right, let's look at 7128. So first off, it says here, consider all the special property that a triangle can have. So for example, you can have an equilateral triangle, a right triangle, an isosceles. There's all these different ways we could draw triangles, right? So without any algebraic tools, just by looking at it, right? Just by looking at it, based on looks, anyone want to take a stab at what kind of triangle this could be, or how can you classify this triangle?
Right.
Definitely right. And what else? Yeah, I heard you murmur it. Say it louder. Yeah, I agree. Isosceles, good. Yeah, I suspect that RD probably equals ND. And I suspect that angle D is a right angle. But with most things in life, you have to prove it. You can't just say. So we need to do the bare minimum to prove it. So how am I going to prove it? So what's the minimum information you need? You need to maybe find slopes. Okay, Griffin, you're gonna say something else. Find slopes of RD and ND. Also find lengths of RD and ND. And that should be sufficient. I mean, you can find RN, I suppose, but we're going to do that later on. So Why don't you guys try it right now? Go and find the slopes. I know you guys can do it. It's not hard. Just rise or run. At the same time, you could probably find a distance if you do a slope triangle. If you do a slope triangle like this, right? Don't you already have a right triangle? How long is this side here? And how long is the vertical side? Yeah. And you're probably gonna get the same thing here. Let me do different colors for contrast. We'll go light blue. That's 6 and 2 as well. And by the way, while we're at it, probably also do that too, just so we get it done. Okay, go and find the slopes. So that's going to be part C. Find the slopes of RD and ND and the lengths of RD and ND. Because now you're using algebraic tools. Griffin, go ahead.
Find the exact lengths of right
Let's leave in radical form. That's fine too. Sure. Sure. So I'm not going to move the screen because I want to keep the figure exposed. So I'm doing part C in pink here. What's the slope of RD? Down what over what? So it's -6/2 or -3. How about DN or ND? Up and over how much? Up 2/6 or 1/3. And let's look at the lengths of each. 6 squared plus 2 squared. 6 squared plus 2 squared. So root 40. Or what factor of 40 is a perfect square? Well, 4, but you pull it out, it becomes 2 root 10, because 4 times 10 is 40. Good. So therefore, again, I'm not feeling like moving the screen. RD is perpendicular to ND, and RD is congruent to ND. So that's sufficient information to prove that we have a right isosceles triangle. So now we've proven that triangle RDN is an isosceles right triangle. So, make sense? Okay. So that's all part C. You could just leave the space for part C. I mean, obviously you should figure out RN because if all the sides are the same, but that would be impossible because you have a right angle. So that would be weird, right? Okay, any questions? How I broke that down. So it's a good review of distance formula and slope. And by the way, those forms will be provided. You don't have to memorize them. They'll be given to you. Okay, now let's look at part D. What's part D asking us? Part D is asking us to wonder if there's anything special about the midpoint of Rn. Find the midpoint of Rn, we'll call it M, and then find the lengths of Rn, Dm, and Mn. And what do you notice? Okay. So can I clear the screen? We good? All right, let's clear the screen. So let's figure out point M. And we're going to connect this. So we got to find Rn. Let's do it again. We got to figure out Rn. We got to figure out Dm. And we got to figure out Mn. Well, first of all, what's point M going to be? So what are we when we're finding midpoint of Rn, so what are we averaging really?
X and Y.
Good. So you're averaging not 1 and 9. you're averaging 7 and 3. If you average them, what do you get? 5, 5, right? So M's 5, 5. And of course, D is 3, 1. So we have to find all these segments. Why don't you go and do that right now? Find what Rn is, find what Dm is, find what Mn is, leave it in exact form, so radical form,
Rn.
all the distances.
Oh,
Yeah, we're finding lengths, guys, not slopes now.
what was the point of finding the midpoint? So just where's
You'll see in a moment. Yeah, you'll see. Let's do the slope triangle for Rn. How long is that horizontal leg in green? Count it. 8. How long do I go down? Okay. So you should get root 64 plus 16 or root 80 or 4 root 5. The DM, if I do this, so if I do Pythagorean theorem to solve for DM, I should get root 4 plus 16, which is root 20 or 2 root 5, which interestingly is half of Rn. And then lastly, let's find this side. It's actually the same thing as DM. Root 4 plus 16, you get the same thing. Now, DM is what we call the median. Now, let me define that for you. It's a new term. The median is a segment that connects the vertex of a triangle with the midpoint of the opposite side. Now, it so happens that we have a right triangle. The median will be also half the length of the hypotenuse. We see that. So it's just an observation, just something to just keep note of. But the definition of a median, so we think like I'm sure you guys doing driver's ed. So who has a license now? I mean, I look at the sophomores. Okay. Okay, but do you drive right now? You don't? Okay. Well, I'm sure you guys, everyone's been in a car, right? Has driven, right? And you have the median of the road. Why do we call it the median? It's the middle. There you go. And if you drive over the median, that's a bad thing because now you're going opposite traffic, you hit someone head on, right? So the median's the middle. So just think of that. It's just middle, and it's touching the middle of the other side, but it's coming from a corner. It's coming from the corner of a triangle. So I think that's all we want to say about that. Nothing much more. Okay, we're gonna skip 129 because I said it's a little too challenging, so we'll skip that. So I'll close that down. Okay, let's talk about 733. We're gonna fill out this table. We're gonna talk about the whole must be, could be thing again. Then I'm gonna talk about another way we could potentially assess this whole must be, could be phenomenon because I know there's a bit of ambiguity. This still has some not ambiguity. This is still confusing, but I still feel it has less ambiguity than the must be, could be. The sometimes, always, never. We're gonna talk about that. And then I'll talk about the tests and we're done. Pat, yeah, Pat, sure, yeah. Okay, so here's what I want you guys to do. So you have a property, and we're gonna put check marks if it's true or not. So for example, I'll do the first row with you guys. If all, sorry, not all, sorry. If the opposite sides of a quadrilateral are parallel, is that enough to say it's a parallelogram?
Yeah.
Yeah, it is. Yeah, because what's the definition of parallelogram? When you have a parallelogram, which looks like this, right? That's your typical parallelogram. These sides are parallel, and those sides are parallel. So 100% making that statement is sufficient. That would be a must be. So if opposite sides are parallel, must it be a parallelogram? Yes. That's the whole definition of it. Now, here's what gets a little interesting. Um, is that true for a rectangle? It is. Must it be a rectangle? Well, no. But could it be a rectangle? Sure. If you had all right angles. And could it be a rhombus or square? Well, at the very least, we know um, that statement satisfies those definitions. So is that true for a rectangle? Yes, it is. Is that true for rhombus? Yes, it is. Is that true for a square? Yes, it is. So all we're doing right now, if you think about it, we're kind of doing could be statements. Or just is it true for that? Is it alone? Alone, could I say that's enough? No, except for parallelogram. That would be alone. So in case you're curious, the MCCC is a must be, could be. Must versus could. Consider the statement alone. Consider that statement alone. So if you consider that statement alone, that would be enough to say a parallelogram. But is it enough to say the other ones? No, but they're true. They are true. Because a rectangle has that. A rhombus has a square has that. But let's just focus on check marks for now. Just does that property apply to these quadrilaterals? So opposite sides are congruent. How many check marks are you going to put? Is that true for all four of the statements? Are the opposite sides congruent in a square? Yeah. Are opposite sides congruent in a rhombus? Yeah. Are opposite sides congruent in a rectangle? Yeah. Are opposite sides congruent in a parallelogram? So basically, you're doing a true false. Think of it this way: you're doing a true false.
Is this like what we are doing, but it must be?
We will dive a little deeper after I finish the table. Correct. Correct. Okay, opposite angles are congruent. Are the opposite angles congruent in a square? Yeah. If I draw a square, aren't the opposite angles each 90 degrees? Sure. A diagonal forms two congruent triangles. That's true for a parallelogram. Like if I draw that, those are two congruent triangles. You have a side angle side. So that's gonna be true for everything else. The diagonals cut each other in half. Well, sure. That's the same as that. And that's the same as that. Sure. Of course. So these first five are always true for parallelograms. Now, are the diagonals congruent? Which ones would that apply to? Yes, good. And what else? That's it. It will not apply to a rhombus, though. A rhombus is like a diamond. You can see here, that is a shorter diagonal. That is a bigger diagonal. So how diagonals are perpendicular? Sure looks like in a square. It sure looks like in a rhombus. But a rectangle? Nah. a diagonal bisects the two angles. So you see this diagonal for the square that I just drew in purple? I know a lot of colors now. Um, yeah, if you look over here, would those each be 45? And a rhombus, those be the same. But that's not quite the same here. That's not quite the same here. So I would go for a rectangle and square in this case. But all the angles are right angles. That's also a rectangle and a square. All sides are congruent. That's a rhombus and a square. So some of these are relevant to just rhombus and squares. Some are just relevant towards rectangle squares. But a square is all of them. So what does this tell me? A square is a special parallelogram. It's also a special rectangle and a special rhombus. So a square is a rectangle. A square is a rhombus. A square is parallelogram. But are all parallelograms squares? No, right. So you have to be able to use some logic in that case. Okay, must be, could be. My quadrilateral has three right angles. Okay, well, if you have three right angles, what does it mean about the fourth angle? It's also a right angle, right? You only have 360 degrees, right? I mean, it still has to be a right angle. So, of course, you're gonna have four right angles. But here's the thing. Would that, is it guaranteed a rectangle? I mean, actually, we could say it must be a rectangle.
This is circle.
So a square is still a rectangle. That's the thing. A square is still considered a rectangle. A square is just a special rectangle
Why is it? Where is the rectangle?
because I don't know if all the sides are the same. So for this to happen, all sides are congruent. We don't know that. But this is enough. So it's all about, is it enough? Is that enough to call a rectangle? 100% it is. That's enough. But you have to dig deeper to make it a square. Do we have that extra information right now? Nope. That's why it could be. Must be a rectangle because you have enough. It's all about having enough. Does that make a little sense? Hopefully. All right. Part B. A quadrilateral has a pair of parallel sides. Okay, I actually hate this question. Because here's the thing. A pair.
Oh.
Does that mean exactly one pair or at least one pair? Like, see, that's the part I'm struggling with this personally. Has a pair. If you really want to be like a lawyer and look at legal language, let's say this. Exactly. Let's insert that word exactly. If you have the word exactly, a pair of parallel sides, then it must be a trapezoid. And nothing else. You see how the wording, attention to detail, can really mess you a little bit? Now, what if I had, I'll switch colors so that we have a bit of contrast. What if I had at least? Then I don't know what it must be, but if it's at least, it could be a trapezoid, could be a parallelogram, or square, or rhombus. So you see how the wording can really throw it off a little bit. So I think when I talked to Mr. Davis, I think we're gonna have to be very clear about the language. Yeah, I just kind of struggle with that a little bit. Okay, and the last one, and I know there's a bit of a terminology. Do you guys know what consecutive means? Yeah, or in sports, I know a lot of you guys talk sports. So like, for example, um, OKC won how many games in a row to start the season? Do you remember? Okay, so they won 24 consecutive games because they won those games in order, right? Now they've won about 30 something games, 37 games, but not all those 37 wins were in order. They lost some games, lots of Spurs a couple times, right? Or three times actually. So consecutive has to be in order, has to be next to. Yeah. Yeah. So like, you won if you win like 10 straight 10 consecutive games, you won all those games next to each other. You won the first game, you won the game that came after that, the next game, the next game, next game, and so forth. So consecutive means next to, just so you know. In case, because I know some people are kind of struggling with the terminology. So it has two consecutive equal angles. Again, I kind of struggle with this one because what if it was exactly? Two consecutive angles. I mean, we definitely have a trapezoid. You have two 90-degree angles. Um, but you could also make it kind of funky a little bit. Like, I don't know, you could do, I don't know, I'm kind of struggling with my drawing here. Yeah, I don't know, man. This is crazy, this one here. So I don't know. I'm not sure. Um, this is exactly. Yeah, I'm kind of perplexed here. You know what? Let me come back to that one because I struggled with this one last class. You know what? Let's just cross that one off for now. Yeah, and let me talk to Mr. Davis about that because I'm having a little trouble with that one. But these are I think are better. Yeah. No, this one I do like. So before CPM, we used to use this one textbook. I can't remember the author of the textbook. It was thick. It's probably somewhere in the back. And the homework used to have these sometimes, always, never type of situations. So is this always true? Is it never true? Or could it potentially work? So a rectangle is a parallelogram. Well, that's always true. All rectangles are parallelograms. That's always true. Is a parallelogram a square? Well, maybe. What has to happen? All four sides are the same, and all four angles are 90 degrees. So that's sometimes. You can't cross it off. Now, is a rhombus a rectangle? Well, no way. No way. Right? Because a rectangle has to have four right angles. Rhombus doesn't have four right angles. A rhombus is a trapezoid? No way. That can't happen. But is a rhombus square? Always. Sorry. No, sometimes. My apologies. That's sometimes. That's because it needs to have all right angles be right. So sometimes it could be. I mean, it has all sides. Is a kite a square? No, never. Never could happen. Okay. So I'm not going to do this activity because I know you guys are kind of spent a little bit. So it's been a long day. Um, so the test, just so you know, you have the outline. If you I also put this in Schoology as well, so you can click on these hyperlinks. These are like textbook problems or CPM, electronic textbook problems, proofs. So definitely have some proofs for sure. By the way, the proofs that you guys did in the poster presentations, those other like the other proofs that you guys didn't do or you did, but the other people presented on, those are in the unit review. So you have a chance to practice that. Um, so you definitely want to practice proofs. You'll have a chance to do in the unit review as well as in the electronic textbook. Classifying shapes. I know must be, could be, other things, naming it, always, sometimes, always, never. So there's some practice there. I think a big one, to be honest, is this kind of stuff, the algebra. I'm a big proponent of these kind of questions. Like Homework 6 and 9, those worksheets where you're given shapes and you had to know the properties and you had to find what X was, you had to make these equations, things like that. These are good ones. Some of these might involve system equations or quadratic equations, factoring, or solving for a single variable. We just talked about median. We just talked about the median, right? We just did that. Trial mid segment, we talked about that last week or 2 weeks ago, I can't remember when. Midpoint, we talked about analyzing shapes. We talked about using distances and midpoints or slope relationships. And just in general, just knowing trig ratios, things like that, Pythagorean theorem, applying those for the things we've done. Don't worry about formulas. You'll be provided all formulas. I'm pretty sure it's calculator allowed. I don't think we would not allow that. We've always had that for our test. Yeah, slope, point slope, slope intercept form, point slope form, quadratic formula, Pythagorean theorem, midpoint, distance formula. And then the homework is this packet, which everyone has. So I want you guys to work on 1 through 9. So if you feel so inclined and you're feeling ambitious, you get a head start and get some of this homework done. You're doing 1 through 9. The answer keys provide as well. So the other packet you have is the answer keys. So you can check your work. We'll do more of these problems on Wednesday. I also prepared 2 more packets, so don't worry. Like, oh, I got this done. I need more studying. I'm going to provide more packets. They're downstairs. I got to go pick them up. The homework's just 1 through 9, this packet. You already have it. And then we'll see if maybe we have adult math or other things we could do. I may have some other materials that might be worthwhile. But for now, we can work through this. And the whole week is all about review. So, yeah, go. Yeah. Sure, go. Yeah.